Here's pre-calc. It's closure problem for chapter 10. It's CL, 10-156. And this one, it asked us to find sine of 2 theta. And it told us what sine of theta was, and it told us that cotangent of theta was less than 0, which means this was negative. So the first thing we did is we talked about what quadrant are we going to be in. So if this sine of theta, this is a positive number, this isn't a negative number, so it could really, sine could only be positive in quadrant 1 or 2, but we can narrow that down because we say cotangent has to be negative. Cotangent is cosine over sine. But we know sine's positive, so cosine had to be negative, so that made us know that we're in quadrant 2. That's what our angle, that's what theta is. And then the next thing we did is we remembered that there's a little formula, the double angle formula. We have it up on the wall. It should be in your magic books and in your math notes boxes. Sine of 2 theta is 2 times sine theta times cosine theta. Well, we know what sine theta is because they gave it to us, so we just plugged that in for sine theta. We had to figure out what cosine theta was, and we know that sine is opposite over hypotenuse, so we drew the triangle. We didn't know the angle measure yet, but we just drew the triangle and we said opposite, right, because the numerator's the opposite part, and then the denominator's the hypotenuse. And then I used Pythagorean theorem somewhere. I think over here I used Pythagorean theorem. I said a squared plus b squared is c squared. And I did all the work and I came out that this side length right here is square root 165. So then I know cosine is adjacent over hypotenuse. So for cosine, I grabbed the adjacent, and remember it's negative over here in the quadrant 2. So adjacent over hypotenuse, so it's negative root 125 over 15. Root 165 over 15. So if you multiply all those out together, they don't look too nice. I didn't know, it wasn't obvious to me, but square root 165 is the same as, 165 is 11 times 15. So if you see in your answer book a bunch of root 11s and root 15s, it's nice to know that. If you didn't notice that, it's fine. I just multiplied them all together in my calculator. I went 4 times root 15 times root 165. My calculator is nice to me, and it actually just calculated that out. Yeah, I mean, anyway, whichever way that you can calculate this, it turns out to be that answer. And so then the next thing is letter B. They wanted the half angle. They wanted cosine of theta over 2. So I grabbed my half angle formula from the wall in our classroom, or you could look it up. And it's 1 plus cosine theta over 2, but we already just got done saying cosine theta was negative 165 over 15. So I plugged it in for cosine theta, and then I thought of maybe a little bit easier way of cleaning up inside this radical. I thought of just splitting it into 2 fractions, because if I did this as 1 over 2 and then root 165 over 15, times a half, that kind of saved some work for me, so I just did it. I thought of it that way, but then I wanted to get them back on the same denominator again, so I multiplied the top and the bottom of this 1/2 by 15 over 15, and so then I was able to get to here. But you can still, if you want to get a common denominator on the top, and then keep flip change or have some other way to do it, that's fine too. Alright, so the next thing is letter C, secant theta. is equal to 1 over cosine theta. Maybe we'll keep our little formulas with the yellow highlighter. So that's just a fact that we know. So we already know what cosine of theta was. Cosine of theta was negative root 165 over 15. So if I want the reciprocal of that, I just turn it upside down. So negative 15 over root 165. And then I wanted to rationalize it, so I multiplied by a giant 1 of root 165 over root 165. And I ended up with this business, and then it turns out that 15 times, remember I said 15 times 11 equals 165, so the 15 cancels out, and that becomes, wait, hold on a second. It should be root 1. Oh no. Alright, so I don't know how to edit, so I'm going to go ahead and I think I might end up redoing this problem on a different video.